Well, hey everyone, and welcome to our physics homework tutorial.
We hope you find this tutorial helpful in your study of physics, and if you do, please visit our website at www.physicsvodcast.com.
There you're going to find over 200 physics examples in every topic of physics. It's sure to help you get through that physics homework. We'll see you then. Hey everyone, here's your Sioux Falls physics teachers moving on to complex circuits. So now we're going to be taking all of these basic ideas on series and parallel and applying them to circuits that combine both together. So we see the circuit diagram given, and it asks for the current through each resistor. Again, a very simple question, but quite a few steps to reach that point. Not difficult steps because they're very repetitive, but we do have to realize that we will be doing quite a few different steps of applying Ohm's law along the way. First thing that we will want to do is calculate the equivalent resistance. And again, when we're going to do that, we want to first label each resistor. So it doesn't particularly matter what order they are labeled in, but for future reference, we'll need to know how we're combining them together. The next rule of thumb, remember, is to start with the smallest possible combination. So here I see that resistance 2 and 3 are connected in parallel. So we want to see what those two would behave like when they are in parallel. For a parallel set of resistances, the value should decrease overall, so we use the inverse equation. This would be 45 ohms and 35 ohms, both to the negative first. And our final answer for the resistance of 2 and 3 together, and notice that it's useful to include that on the subscript for our label, is 19.7 ohms. So now we can think of this combination here as being 19.7 ohms for the two together, and that means that our equivalent circuit is really resistor 1 of 15 ohms in series with the resistors 2 and 3, which are 19.7. So to find our equivalent resistance for the entire circuit, we'll be looking at 15 ohms, and because they are in series, we would simply add them together, added to 19.7 ohms, and that means that our equivalent resistance is 34.7 ohms. Now again, notice that the equivalent resistance was never actually asked for in the question, but before we do any further application of Ohm's law, we need that total amount. Now we can take that amount of resistance and include that in Ohm's law applied to the entire circuit. So we have 6 volts as our total. The equivalent current is our unknown, and 34.7 ohms. Solving for equivalent current, we find that we have 0.17 amps. Now, even though this is not specifically asked for in the question, this is an important amount, because remember that for a series circuit, if we have 0.1 amps leaving the battery, that current then will have to travel first through resistor 1, then continue on to the parallel combination of resistors 2 and 3. So we have, in fact, just answered one of the questions, because all of that 0.17 amps will have to travel through resistor 1. So even though we originally labeled this as equivalent current, we can also label it as current through resistor 1. Now notice that that's not going to be the same as the current going through resistors 2 and 3, because when that charge reaches this combination, it's going to split. Some of it will continue on through the 45 ohm resistor. Some of it will continue through the 35 ohm resistor. So we need to be able to figure out which one or how much will go through each resistor. And for that, we're going to need to know the voltage across those two resistors. So again, kind of another step of Ohm's law, not to directly answer the question, but to get us some information that we'll need to answer the question. We know that the total current for 2 and 3 together is 0.17 amps. And we also know that the equivalent resistance for the two together is 19.7 ohms. And so we can find then that the voltage across those two resistors is 3.4 volts. Now that we have the voltage across 2 and 3 together, now we're ready to break it down one step farther and apply Ohm's law to the single resistors. So for resistor 2, the voltage is 3.4 volts. And again, remember, we've labeled this 3.4 as the voltage for 2 and 3 together, but because they are in parallel, they will each get that voltage. The current is our unknown. Resistor 2 was 45 ohms, and that gives us a value for current 2 as 0.076 amps. Now we can repeat the process, which again I've already done here to save us a little bit of time, for resistor 3, again using the same voltage of 3.4, using its individual resistance of 35 ohms, and we get a total current through resistor 3 of 0.097 amps. Now again, notice that between currents 2 and current 3, we have a double check. They should add to give us the same as our total for the circuit of 0.17. And as you get more comfortable, that also will give you a little bit of a shortcut to doing this, because as soon as we found current 2 to be 0.076, we could have just subtracted to see what was left for current 3. So our final answers then, 0.17 amps going through resistor 1, and then splitting for 0.076 through resistor 2, and 0.097 through resistor 3.